Good morning, Jack Davis, SDSU Extension Field Specialist. We'll get started with our ag economic dialogues today. We were going to have Laura Edwards do the weather, and she ended up, of course, affected by the weather and stranded in Deadwood with her. So she's not able, and we got a substitute. So Darren Clabo?
Clabo, yeah, Clabo.
Clabo, okay. And he'll introduce himself a little, and he's going to go through our weather today.
Sounds good. Thanks, Jack. Let me get my screen up. Yeah, good day. My name is Darren Clabo. I am a professor of practice at the South Dakota School of Mines and Technology in their Atmospheric and Environmental Sciences program, which is tied into our Department of Civil and Environmental Engineering. I'm also the state fire meteorologist for South Dakota, so I deal a lot with wildfires, weather, and climate, and hence my relationship with Laura Edwards. We work very, very closely together, and she gave me a opportunity to present to you all today because of her unfortunate travel situation up in Deadwood. So I'm going to talk just about our winter outlook, go through some kind of near-term forecasts, and then extend that out into what we're expecting for the rest of the winter, and of course going into the spring months as well. So let's just go get started. So looking back, let's just kind of think about what we've seen over the past 6 months, 3 months, 6 weeks. This image here is the fire scar from the holiday fire over on the Crow Creek Agency by Fort Thompson. That fire burned about 3,000 acres one afternoon. The origin point was kind of in the bottom center. Strong south winds that day, and it raced off to the north. We did have a lot of wildfires this fall and late summer months across the state, from the prairies to the hills. You know, nothing too extreme out there. You know, there's some very good firefighting work that went on to really corral those fires, but we did have some fire activity, elevated fire activity because of the dry situation that we're in, and I'll get into that more here in a minute. Looking back, these are our growing season temperature ranks. So we're considering our growing season here to be April through September. The warm colors you see on the screen are temperatures that are above average for that entire 6-month period. There are no cool colors on this map, so nearly all of the CONUS was above average in terms of temperatures during the growing season. And the hottest temperatures we saw were across New England and the southern Great Plains down into the desert Southwest. South Dakota was above average. We were in the top kind of 50th percentile, close to the 70th percentile in terms of our overall temperatures. So it was a warm summer. And you know, when we start to see these temperature ranks extending over 6 months, it really goes to show that we did see those above average temperatures. And if we look at our precipitation during that same time frame, by and large, South Dakota did okay. There were parts of South Dakota, and of course, this is a statewide kind of averaging that goes into this. By and large, South Dakota was average-ish over that same time period. There were some areas that saw pretty good precipitation, especially northeastern South Dakota got pretty good precipitation, especially in the early half of the growing season. Southwestern South Dakota, Black Hills didn't see quite as much precipitation, but it was very convective in nature. And when I say convective in nature, I really mean that we're talking thunderstorms. And so that precipitation wasn't widespread. It was very, very spotty, and it was very hard to come to kind of a consensus on how to characterize it, especially for the U.S. Drought Monitor. I know there was some consternation out there with how the Drought Monitor was projecting our situation throughout the summer months, but it was just an incredibly difficult year to really discuss precipitation in broad terms across the state. Looking back to September and October, obviously this fall has felt very, very hot, and it has been extremely warm. We were in the top 10% of the warmest years, and that's a 128-year record here in South Dakota. So we saw very, very warm September and October. Oh, and I do want to go back to our precipitation ranks. One thing that was very unique, and Jack and I were talking about this before the presentation started, was that North Dakota, especially in the early half of the growing season, saw an incredible amount of moisture, and that boosted the river levels on the James River, especially coming out of North Dakota. And so while we did see some localized flooding in that area, by and large, most of the rest of the area was dry, and that dryness continued into the fall months. Not only that, but it was hot. And so the evapotranspiration rates were up. We were taking a lot of moisture out of the soil, which is not something we want to do. in the fall months. We really need to lock in that soil moisture, and we just didn't get it. In fact, it was one of the driest falls on record for all of South Dakota. And so I think some places received very little, if no precipitation at all for a 60-day period, which is pretty incredible if you think about it. So dryness persisted this fall. And that really led to our soil moisture deficits across the state. This is a calculated soil moisture anomaly product from the Climate Prediction Center. This is millimeters of moisture, the departure from average. And you can see that the bullseye of that dry soils is really across southeastern South Dakota, but it does extend into the rest of the state. Here's our current U.S. drought monitor. This is as of yesterday. And, you know, there is kind of this sporadic, sprawling drought across the state. Nearly all of the state is in D1 or higher drought conditions. There are a couple pockets of D0 abnormally dry conditions out there. South Central, Southeastern South Dakota are really seeing kind of the biggest impacts from the ongoing drought. And this has been some big changes. This is our U.S. Drought Monitor class change for the past 13 weeks. The brown color, well, the yellow to brown colors you see across South Dakota means that we've seen, you know, 1, 2, 3 category degradations in the U.S. Drought Monitor over the past 13 weeks. And again, this just kind of goes to show you how dry and hot our fall has been. Again, in a time that we really need precipitation to lock in soil moisture. Missouri River, there's issues all across the Missouri River Basin, the Mississippi River Basin. Maybe you've heard of some of the shipping issues across the lower and central Mississippi River. The Missouri sure isn't feeding in a lot of water into the system. On the right, you can see that our system storage comparison from previous years. This bottom line is a red year, kind of a similar year. 2013 was really low. And of course, 2011, record flooding through the basin. So we're definitely below historical averages. And I know that the U.S. Corps of Engineers is kind of limiting some water releases out of the dams to kind of their bare minimums throughout the winter months, because we do not expect much precipitation across the Missouri River Basin going through this winter. So looking ahead, and I put this picture in here, this is up Spearfish Canyon, kind of in the northern Black Hills. I put this in here just for Laura, so y'all could understand kind of the road conditions that she would have been facing if she would have been coming down the hill trying to get back to Aberdeen yesterday. But yeah, just not safe conditions to be driving in. And of course, looking ahead, we are looking forward to a winter coming up. Short-term forecast, we're not going to get a lot of precipitation. We're really trending towards what's called the big upper level ridge. Should bring us some warmer than average temperatures going into next week through the Thanksgiving holiday, and we're not expecting a lot of precipitation with that. And that's really unfortunate. And our soils are so dry, and with this cold snap that we've been seeing, we're already seeing, you know, 1, 2, 3, 4 inches of frozen soils, which is not going to allow any moisture that we do get in the near future to really sink in and lock into that matrix. Short-term outlook, this is 6 to 10 days. Again, we are expecting some warmer temperatures to move into the region. As you can see on the left-hand side, the warmer colors are high confidence of above average temperatures, and cooler temperatures expected across the northeastern part of the United States. Combined with some higher potential, maybe drier than average conditions across southwestern South Dakota, with average or near normal conditions projected elsewhere. And again, I have to stress that average precipitation this time of the year really isn't a lot. I mean, December, especially December and January, 2 of our driest months of the whole year. Here's a 1-month outlook going into December. This was an outlook produced by the Climate Prediction Center yesterday, and really no strong signals one way or the other. There are some tendencies for cooler than average conditions across the northern tier counties of the state going into December, and that's really a signal of the La Nina, and I'll get to more of that in just a second. Equal chances of above or average or below precipitation for much of the state. Some hints that the Pacific Northwest coming into the northern Great Plains could see some enhanced moisture in December, but I would not hold your breath. Again, we are still in a La Nina. La Nina is a cooling of the eastern equatorial Pacific waters off the coast of South America that affects global circulation patterns, and it can kind of change what we see here in the northern Great Plains. We can look back look at other La Nina years to try to figure out, hey, what happened during those years? Will we see similar conditions this year? Because kind of that whole global circulation, a global weather pattern shift. And by and large, La Nina winters are cooler than average across the northern Great Plains. However, there are a couple of notable La Nina winters that were warmer than average, including 1999 and 1998. It was kind of a back-to-back La Nina year where we did see warmer than average conditions. But looking historically at these La Ninas, hinting towards cooler than average conditions. And if you make out the northern Great Plains, kind of North Dakota into Minnesota, you'll see those cooler than average temperatures. And really the Climate Prediction Center's forecasts are hedging their bets towards those La Nina conditions that are favored, again, cooler than average winters. And I do want to add that cooler than average winters, it's really more of a January through March winter. So think of last year, or actually, well, this year, but last winter, January through March were pretty darn cold across the state. And it wouldn't surprise me at all if we see those types of conditions once again. On the right-hand side is our proxies for precipitation. Really, there's no strong signals of above average or below average precipitation during La Nina years. So kind of to summarize, average precipitation with a La Nina year tends to be below average temperatures with a La Nina year. And again, I want to stress that during the wintertime, it's not our wet season anyway. So we just typically don't get a lot of precipitation anyway. We're expecting La Nina to continue through at least the middle of spring into potentially the end of spring. And this is just a chart showing the probabilities of La Nina continuing. There are 3-month bins on the bottom. So OND is October, November, December, and then we have November, December, January. And that's kind of how we track La Nina. So yeah, we're expecting La Nina to continue through at least the January, February, March timeframe, likely to continue through March, April, May. And then we're likely to shift back to a ENSO neutral is what it's called, or a neutral phase of the oceanic index. Some hints at maybe an El Nino popping up this summer, but again, those are just hints at this point. And this La Nina, I want to add, is very, very unique. It's a La Nina three-peat. This is our third consecutive year in a La Nina. Historically, looking back at the past 70 years of records, we've only seen 2, maybe 3 time frames when we saw back-to-back La Nina years. So even looking back at the proxies of other La Nina years, it might not be a very good statistical relationship. But we'll move forward with the forecast. Here's our 3-month outlook. This is for January through March of 2023. Again, hints towards colder than average conditions across the northern Great Plains, and that's really in line with what a average La Nina year is, and really no hints of above or below average precipitation during the same time frame. Again, that's really reflecting a La Nina year. Looking out even further, March through May, there's no strong signals either in the temperature or in the precipitation for our area. I'd really like to see this map give us a big blob of green across our region, but unfortunately, we're just not seeing the signals that would give us any indication of good precipitation this spring. So that's about all I have. Happy to take any questions after the presentation. My contact info is here. Feel free to follow me on Twitter. Feel free to call or email anytime you want. I'm available to answer questions as we go through the winter months, or if you're more interested in the wildfire seasons, yeah, feel free to reach out. But thank you.
Thank you, Darren. And then we, and Jason, if you could load your slides and we'll go through that. I guess one thing that I would say to the audience listening, there's the pasture range forage product that can help ensure, what does it for rainfall? I guess if you don't get rainfall, you get paid, and that deadline is December 1st. So you got the kind of the holiday week and a little bit after to possibly sign up for that if people are interested. All right, we have with us now Dr. Jason Clark, our soils person or fertilizer expert at SDSU. So we'll let Jason take it away.
All right, can you see my screen okay?
Yes, it works.
Okay, perfect. All right, so yeah, I'm Jason Clark. I do soil fertility, corn, soybean, and wheat for South Dakota, and kind of go through the economics of corn nitrogen fertilizer decisions today with us. So just kind of wanted to get a little bit of background since more of an economics group here. So just to kind of show us how we do a lot of these trials and how we come up with these recommendations and guidelines. So a lot of times what it takes is we do a lot of field trials. We'll take a field and kind of grid it out like this. We'll take nitrogen rates going from 0 to 200, 250 pounds per acre and randomize them throughout this area right here. And then we're going to take those yield response, how each of those areas yield. I'm going to take this graph right here. So we have a low yield to high yield on our y-axis, and then we're going to go look at our x-axis where we have nitrogen rates from those low rates up to high rates. And then we're going to look at the response of how that yield increases as we increase in nitrogen rate. And most importantly, we want to know where that point is right around here, where we're optimizing or where we're getting that maximum yield and what nitrogen rate that is. So that's kind of that key thing we're looking for in these instances. So if we look at some actual data from a field, this is in Salem, South Dakota, and we have our corn yield on our y-axis over here in bushels per acre from low to high, and our nitrogen fertilizer rate in pounds per acre right here. And we're going to look at those yield responses we get from yield increments. So going from 0 to 200, we can kind of see here, and we can do some different math and kind of connect those dots the best we can to see where exactly that line kind of stops moving up. And these are just two different ways, two different models of looking at it. In my opinion, you take these two models and you average them so that you're optimizing that 225 bushel per acre yield at this site between about 90 and 120 pounds of nitrogen per acre is where that optimum level is here at this site. If we want to look at, what is common in South Dakota, I don't know that there would be anything common. As you can see on this slide, we have a pretty big range going anywhere from, this is our y-axis for economic, that nitrogen rate requirement, and these are just 34 different sites. So we have a bunch down here that didn't have a response. They yielded without nitrogen just as well as they did with it. And we can see we went anywhere from 35 to 200 pounds of nitrogen per acre needed at these various sites. But the thing that's interesting, if we take this and look at this nitrogen requirement and look at it versus yield, we don't see a very good correlation. You see good yields when we didn't require nitrogen, good yields when there are smaller amounts, and similar yields when there are higher amounts. So just knowing our yield doesn't give us a perfect explanation of how much nitrogen. It does help some. So this is kind of looking at some of the data. So then how do we make these decisions of how much we're going to put on our field? And that's what we're going to look at next. So we have two main systems. We have what we call a yield goal system, which is right here. And that's what we currently use at South Dakota. But there's another system that's been around for a few years, and it's called the maximum return to nitrogen. And this one, when we're looking at this response curve, it also plugs in economics of how much bushels per acre that corn price versus that nitrogen fertilizer price, and kind of does some stuff there. But just a little background on the yield goal, that's this right here. And if we kind of blow it up and we look at this equation, if we're going to decide currently how we're going to do it, we're going to take our yield goal and we're going to multiply it by this number right here, 1.2, which is the pounds of nitrogen needed per bushel of corn, kind of shown over time. And then we're going to subtract the amount of nitrogen in our soil. If we grew soybean or alfalfa before, we'll give that a credit. And then if we are just newly into no-till, we kind of need to increase that rate just a little bit. So just for an example, if we look at this next one, if we take our yield goal, say our yield goal is 144 bushels per acre, we multiply that by that coefficient, that pounds of nitrogen needed per bushel of corn, and then we subtract that soil test nitrogen and say we grew soybean before this, so we're going to use a legume credit of 40 pounds of N, and we're newly no-till. So, we've only been in 3 years, so we're going to up it just by about 30 pounds. If we do all that, we have about 105 pounds of nitrogen per acre, which would be the current SDSU recommendation. And say we're going to use urea, which is 46% nitrogen. Our recommendation would be 228 pounds of urea per acre. So that's our current system. And the kind of question with this talk, along with what we're also working on in my program, is what about economics? And so that's where we're trying to go with things, is how can we incorporate economics into this decision? Because right now you can see right here, we don't have how much corn prices or nitrogen prices. It's just a straight recommendation. So if we look at this site again in Salem, South Dakota, and we model it with this line here and see how much, so we required 120 pounds of nitrogen per acre with it. And then as we see, if we just look at this zero right here, without putting any nitrogen on this site, we're getting about 110, 120 bushels per acre. So that's at zero. So next we're going to look at if we add that 40 pounds of N, we get 54 bushels per acre from adding that. So we increase about 120 to 175 bushels per acre. Now, if we add this next 40 pound increment, we get an additional 34 bushels per acre. If we go up to the next one, we get an additional 14. So you can see it's not a linear relationship most of the time. If we add 40 pounds, we get 54. If we add 40 more, we get 34. If we add 40 more, we get 14. So you see this decreasing trend. If we were actually to go above this and add another 40 pounds of nitrogen, our line would be up here, and you see we get no more increase in yield. So that would just be money wasted by putting more nitrogen on. So we kind of look at this a little bit in a table form. If we look at each of these nitrogen rates at 40, 80, and 120, our yield increased this amount. And our profit using $6.79 corn, we saw adding that first 40 pounds, we got $367 per acre. Then adding 40 more, we got 231 more and $95 more. Now, if we look, we've known and seen that price of nitrogen has been pretty volatile over the last year or so. If we were looking at 60-cent nitrogen, this is the amount of profit we're going to get from the economics of it. Start out with 343 for the first 40, 207, 71. So you can see how we're decreasing in the amount of money we're getting back for every 40 pound increment. If we move up to $1 nitrogen, which is close to where we are right now, you can see how that diminishes even more. So we're looking at our totals. We have 60-cent nitrogen, $621 per acre profit from nitrogen. We're only $573 for $1. So the next question is, well, what if we put 160 pounds of N on there? So we don't see a yield increase. We don't see that profit. And we're actually seeing from adding another 40 pounds of N, that's 60 cents of nitrogen, that's minus $24, minus 40 for here. And we're seeing we're decreasing by getting there, by adding that extra nitrogen at that point. So if we know the economics are important because we don't want to add too much because we're decreasing here, we want to be able to, have this amount right here, not this one down here. So one thing, our current system, if we just look at it right here, there's not a whole lot of ways to do it. If we just do it straight across, it'd be 125 pounds of N. This number right here is the only one that we've been thinking about changing right now. And if we look at how it changes, we can see how the nitrogen rate changes. And the reason we're looking at changing it is because over time we've seen in about 1975, that number was about 1.45, 1.3, and 82, 91 is 1.2. Here in 2022 of recent research, we've seen it's about 0.9 or 1. So we can see over time, usually our corn, whether it's new hybrids or whatnot, is becoming more efficient. So we're seeing a decrease in the need for nitrogen. So that's kind of one way, but that's still not putting economics into it. So if we look at this other approach we talked about, this maximum return to nitrogen, it incorporates money, the cost of different things, and we'll show you here. So if we look at this graph, it's similar to our other ones. We have our corn yield in our y-axis over here. We have our nitrogen rate in our x-axis right here. And we're going to see this is a site this year in Brookings, South Dakota. We're going to look at it and we can see the response right here. And if we're looking at that optimal rate, that's going to give us our most yield. That's this rate right here, 85 pounds of N, 224 bushels per acre corn. However, that's the agronomic. We saw that as we increase in nitrogen, this line doesn't kind of go linear. It slowly decreases. So we want to know is what's the rate of nitrogen that the increase in corn yield pays for itself. And that's this rate right here with current corn and nitrogen prices. So you can see we are about 85 pounds of N to get that agronomic yield. We want to look at economics, it's actually around 76 pounds of N. And so it's only about a 9-10 pound of N increment, but we have $1 per pound of nitrogen cost. You know, that's $10 per acre savings. And if you have a 160 acre field, a quarter section, you know, you're looking at $1,600 savings for that field, which if you have multiple fields, you can see how that, even that 10 pound increment can add up over time economically. But one other thing we can look at instead of just looking at our response curve here, if we want to switch this y-axis over here, instead of looking at corn yield, we want to look at net return. So that's what this is right here. If we just want to look at net return, and this is just for nitrogen, this doesn't look at equipment costs or application costs. This is just the cost of the nitrogen. So here again, we're looking at dollars per acre. So we're switching and looking at net return for each of these increments of nitrogen rate that we're putting on. So if we just look at nitrogen costs, it's a linear relationship. We've seen that as we increase in rate, the nitrogen cost is going to increase. This next one is we're going to look at, this green line is going to look at yield return to nitrogen. So that's the amount of yield we're getting for each pound of nitrogen we're putting on. And it's going to look similar to the other curves we've seen, how it goes up. So we're getting a good return to yield, but eventually we flatten out right here and we're not getting any more yield for nitrogen putting on. So if we want to incorporate these two lines right here, that way we can look at our net return. So we see our net return increases like our yield return, but slowly it's decreasing. And eventually we're going to be putting more nitrogen on and we're not going to get enough yield back to pay for that nitrogen. So if we do that right here, we kind of hit that peak, and that's around 75 pounds of N per acre. And if you kind of do just plus or minus on 1 pound of nitrogen or $1 per acre, you're going to get that range about 70, 80 pounds of nitrogen per acre. And these lines actually represent about 34 different locations throughout South Dakota from 2018 to 2022 worth of data. So this is kind of what I would call the state average. And this also incorporates some drought from this year, which is why this number is a little lower from what most of your farmers would think of. If we were just to focus on eastern South Dakota, this number right here of 75 would actually be about 120 pounds of N. But if we're incorporating eastern and central South Dakota, which we won't do in the long term, it's around 75. But so this number in eastern South Dakota is about 120. In central South Dakota, if we just look at those sites, it's about 80. So just to kind of look at another thing, if we want to see how this changes with nitrogen costs, we can look at this graph right here. And on this graph, we can see this blue line represents, and this star represents, if we had $5.50 corn and we have 40-cent nitrogen, our cost or our fertilizer recommendation using economics would be about 140 pounds. If we increase to 60-cent nitrogen, we move to here, 80-cent nitrogen, and this is around 95-cent nitrogen, which is close to what we're doing here. So you can see from going from 40-cent nitrogen, which is what we've been at a long time before this last year, our recommendation would have been about 145 pounds of N. If we switch and look at through economics, and that increase in nitrogen cost without an increase in corn price, we're actually seeing around 90 or around 100 pounds of N per acre. So you can see how going from, if our corn prices don't keep up with our nitrogen costs, how that changes there. And just to kind of show an example of this, we'll see if this works. Can you see an Excel sheet now? Hopefully.
Yes.
Okay, perfect. So this is that same field. And so you can see right here, I'm just going to kind of change some numbers. So right now we have a $1.03 nitrogen price. That's our current one. If we go back about 3 years and we're looking at about 40-cent nitrogen, you can see how that blue line moves from about 76 up to 81. The red line, again, is our agronomic one. It doesn't change. It's just where we see that maximum yield. So if we change this, we can kind of watch this line change as it increments. It's not huge increments because we're staying, our corn price is about the same. You kind of see how that changes, how it's slowly shifting down. If we're seeing a huge increase in nitrogen, we go to $1.25 N, $1,000 per ton of urea. We're looking at, that changing by, about 12 or 15 pounds of N per acre less. And this is just an example of one site. If we were to all of a sudden, if we're looking at corn prices a year ago, or a couple of years ago. We're still down in that $4 range. You see how much that shifts over. It's about 20 pounds less. If we're looking at about corn prices of $5 corn where we were last year, it's still around 70. So you can see how this kind of shifts based on economics. And we can also do a similar thing if we want to look at just not that corn yield. We're looking across all the data for South Dakota. We can see this right here. And right now this is looking at that dollar. So this is that number right here. So it's about 100 pounds of N per acre across all 34 sites for to kind of take averages of there. But if we were to increase that cost of nitrogen, oops, that is not what we wanted to do. To get in the right cell here. So that increase of nitrogen goes, we can see how that pounds of acre recommended goes down, that range right here, and the that net return is this amount right here, how that changes. If we were to drop back to, that 40-cent corn, or 40-cent nitrogen price, you can see how that actually increases. We went from about 100 pounds of N per acre to recommending about 135. If we back down to corn prices to where they were, about $5, we can see how that then shifts a little bit more down to 124. So you can see how this kind of shifts according to corn prices and fertilizer prices. And some people will say, well, how am I supposed to know my corn price, my fertilizer price when I do it? That's where you talk to Jack and other people and look at your economics and see, doing your best guess about what the markets could be. This is really a tool to kind of help people look at how, price of corn and price of nitrogen fertilizer can affect those decisions. So when it jumps up a bunch, like it has the last couple of years, we can see how, effectively moving it down helps us with our net return. That focus on the dollars and economics more than just, maximizing my yield. Just because I get my max yield doesn't mean I'm actually making money at those last increments of nitrogen. Because if we remember from the previous slides, just going to pull this over here. That increment that we're looking at, we see how that goes down. And that's why that nitrogen changes, because we go from a 54 to 34 to 14. And this is just a typical site. Every site's a little different, but we can see on average how reducing that can help our economics. That's kind of the most of what I have.
Thanks, Jason. It's real interesting how that, from an economic standpoint and your yield standpoint, how steep those returns are on that beginning part of nitrogen, and then how it just levels off so fast and just stays. And then when you put the profit in it, how it dropped, so quick as long when on that one where we were continuing to add nitrogen that we saw no response to. That's just, it makes it interesting, and key not to probably over fertilize on the nitrogen side.
Yeah, because you can see, really once we get above this point, we're not increasing yield. And so you can see if you're guessing, clear over here,
Yeah.
you're going to see how much different your profit is versus here. And you can see right here, our economic, it's pretty close to our max yield. It's usually around 97, 98%, but this last couple percent is just economically not worth getting most years.
And as you talked in the economics of it this year with the volatility, guys probably want to look at, or at least look closely at pricing maybe some corn if they're buying fertilizer, and possibly maybe spreading out some of the purchase of fertilizer. Because we just don't know what's going to happen with it, and it's so volatile and so many outside influences right now.
Yeah, there's a lot of influences, a lot of world economics that go into those fertilizer prices and natural gas and many things that go into it. I was at a meeting this past week, and someone gave talks, and there's just so many components to it. So it's going to be hard to guess, but no one really sees it going down anytime soon.
Okay. Well, Darren, do you have any other thing to add?
No, I'm good on my end, Jack. Thank you.
I wish we could have got some rain, like you said, before everything freezes solid here. In the 3 years of La Nina, so that makes predictions real tough too then. And of course you can't predict way out, but if we stay cold into the spring, even that moisture is tough to get into the ground then too. So yeah.
Yeah, and if we freeze up real thick this winter, you know, if we get a good spring rain, it's just going to run off before the soils have a chance to thaw out. And so I do have a lot of concerns going into this winter.
Yeah, when it's dry, will the frost go deeper? Or
yes,
it will. Okay.
Yes, and that's actually a lot of concerns that brings into more thoughts, even some water pipe issues. Just, you know, when you get that frost going so much deeper to the soil, because moisture in your soil is really, it's an insulating factor as well.
Okay. Well, we'll hope, I guess, at about calving time, it warms up and we get moisture for the guys.
Yeah, we're definitely hoping for that.
Yeah. Well, thank you for joining us today, and we will call it for today. Thank you, guys.
All right, thanks, Jack.
Thank you.